My name is Danny Traphagen, and I'm a Senior Startup Solutions Architect here at AWS. I have a background in science and startups both. I come from a long history of building companies from the ground up. I helped to bring a company through IPO as an early startup employee. So today, I'm going to unpack both why and how startups are shaping the next frontier of innovation in the cloud through a mission of sustainability. I am fortunate enough to be accompanied by Akhil Aryan, a co-founder and CEO at Ion Energy, who will walk us through their mission, their architecture, and how they are accelerating Earth's transition to an all-electric future. First, startups must be agile. We love startups because they disrupt and transform entire industries. They reshape how we consume, making our lives even easier with the types of products and services that they produce. And most importantly, they do this quickly. The photo that you see to the left is of the Model T assembly line in the 1920s. 100 years ago, this concept reshaped manufacturing, making it far more efficient. This led the transportation industry into a golden era. Now, fast forward 100 years, and the transportation industry looks much different. There are new challenges as some of the biggest companies shift to an all-electric future. Yet the assembly line remains an area of continuous innovation. Rivian is a well-known EV manufacturer who is taking advantage of HPC, high-performance computing, workloads on AWS. They have reimagined their path to manufacturing by using a computer-aided engineering pipeline. To deploy more rapidly and at reduced costs, they test the viability of their designs as simulations. With vehicles becoming even more data-driven, there are increasing demands to evaluate builds prior to ever reaching the assembly line. For Rivian, this need was especially expedited in 2020, when resource bottlenecks in their on-premises HPC clusters began to impact their product lifecycle timelines. They had 2 HPC clusters with 2,000 cores and rapidly needed to scale their infrastructure to manage against failures and meet their product delivery date within 6 weeks. They evaluated how long it would take to get their on-premises infrastructure up and running. 6 months. With AWS, they were able to launch a POC in just 3 weeks. This was a game changer for them. And it underscores that startups need the agility of AWS services to spin up computing resources faster and focus on what really matters, which is their product. Rivian's computer-aided engineering environment is based on the scale-out computing reference implementation, which you can view at the link on the screen. Within it, you'll see how they used EC2 to schedule and launch instances and Amazon FSx for Lustre as their high-performance file system, amongst other AWS services. Next, building off of the previous point, startups need to have the right tools for the right job to move quickly. AWS has over 200 services and counting. And by the time reInvent is over, this statement will be outdated. Since I started at AWS just 1 year ago, we've already launched dozens of new services. The pace of innovation here is mind-boggling, and that's because our customers set our course. Customers truly define what we build at AWS. Our roadmap is 90% customer-led. The range of technology options runs the gamut, from storage to compute, AI ML, IoT, data lakes, and analytics. We're building at the edge of what's possible, and that suits the startup DNA where the bleeding edge is the primary option. Lastly, startups need to ensure that they are running efficiently across organizations. They must be built lean. If you look at most companies' on-premises infrastructure management, to even get a server typically takes 10 to 12 weeks. As we saw with Rivian, it was 6 months. But then, even more time-consuming, you have to build all the necessary surrounding infrastructure software to manage your startup's compute, storage, database, analytics functions, even ML. In the cloud, you can provision these in a matter of minutes. You can get a POC up and running within a matter of weeks, and you can access over 200 plus services that you do not have to personally build and maintain. You can put them all together to best fit your business needs. This gets you from the fail fast stage to implementation on a completely different timescale than would otherwise be possible. Let's unpack some of the core attributes of building a lean startup. First off, because of the pay-as-you-go pricing on AWS, startups do not have to estimate how much computing resources to provision and pay up front for computing infrastructure. Instead, with AWS, startups can pay for only the resources they use, much like you would for utilities such as electricity. Secondly, you can launch faster. AWS's on-demand infrastructure allows startups to spin up computing resources in a matter of minutes with just a few clicks in the console, instead of months that it would take to set up hardware on premises. This increases the agility of startups, and this And this type of speed is critical in business. Next, you can experiment often at lower risk. Thanks to the cost and efficiency benefits of the cloud, startups are able to experiment often and fail fast with lower risk. They can disrupt and innovate by essentially testing a series of hypotheses. Their hypotheses are not always right, and their ideas might fail. But the advantage that they have with cloud computing is that they can experiment at small scales and within multiple iterations without risking upfront investments that they made in servers or owing ongoing payments if they decide to go in a different direction or deprovision those servers. The ultimate benefit of this is that experimenting often also increases the likelihood of finding the right direction to success. Lastly, they can focus on core business values. All this means ultimately is that startups can focus on their core business. They should be great and focus on the service and products that they provide to their customers, not at provisioning, operating, and maintaining hardware servers. By allowing AWS to oversee these tasks and provide IT infrastructure services, startups can invest more of their limited resources into actually growing their business. So next, let's dive a bit deeper into some example customer use cases and solutions in the sustainability startup space. There are a multitude of startups already creating products, services, and tooling that lead to more sustainable practices across a wide array of industries. Some of them you may have heard of, while others are probably totally new. Since there's a lot of terrain to cover here, I've selected a few to dive a bit deeper into. As we already addressed some of the sustainability work that Rivian is doing, let's walk through what other startups are building. Did you know that 75% of our leading global crops depend on our pollinators? Pollinators are essential to food production. With threats like pesticides and habitat loss, bees make an incredible focus for sustainability efforts. Beewise is a startup focusing on that mission and conservation. Their interconnected network of distributed beehive devices allows for them to collect large amounts of data in real time to monitor bee health. Their product heavily relies on AWS services like AWS IoT Core and AWS IoT Device Management to provide a centralized repository of the data Their product heavily relies on AWS services like AWS IoT Core and AWS IoT Device Management to provide a centralized repository for the data in aggregate. As an outcome of their product, they were able to increase plant and honey production while decreasing bee mortality rates from 40% down to 10% in their robotic beehives. An example in sustainable agriculture is the great work being done by CropX. They are a soil sensor and analytics company, improving crop yields and reducing water waste. CropX is helping farmers address challenges by using more accurate in-soil data sensors instead of the above-ground data, which is often manually collected. CropX is helping customers address these challenges by using far more accurate in-soil data sensors instead of above-ground data, which is often manually collected. However, when they set forth on this mission, CropX was limited by the lack of scalability of in-soil data sensors. To solve this problem, the company chose to run its in-soil sensor data solution on AWS. The solution captures data from thousands of global soil sensors and combines that soil sensor data with above-ground data sets to get a comprehensive view of soil health. The data is then integrated with imaging, weather, topography, and soil data, and analyzed by an AI-based algorithm to provide analytical insights via the CropX web or mobile app. By running on AWS, CropX is able to help its farming customers contribute to increased sustainability by using less energy and fewer resources. For example, farmers can use a digital application to manage irrigation systems and spend fewer resources on travel and equipment. Farmers can also use soil data insights from CropX to maximize their yield potential and better control irrigation and eliminate over or under irrigation. During experiments using its technology, CropX has demonstrated more than 40% water savings across different crop types with a 10% yield increase. AWS infrastructure and services have also supported significant growth in the company's business. Since its launch in 2017, the company now has over 1,200 farming customers worldwide and has almost 9,000 sensors deployed. Recent supply chain headlines have likely brought maritime shipping into your consciousness. Transporting our day-to-day goods through maritime shipping accounts for approximately 3% of total global carbon emissions. Interestingly, of the $200 billion in revenue made by the shipping industry every year, about half of that, or $100 billion, is used to purchase fuel. So assessing more efficient shipping routes is essential to cutting back our carbon footprint. So far Ocean is servicing that industry by building the ocean's largest sensor network, and does so with help from AWS. Not only are there increased regulations for carbon intensity, but there are crucial economic factors to optimizing our trade routes. So far Ocean's Wayfinder app provides the world's best ocean forecasting mechanism. With some analysis that they conducted, So far has been able to save captains 8% in fuel costs. Now, for our customer highlight, we will discuss Beta Technologies. Beta develops an electric vertical aircraft, which we will unpack next. Aviation today accounts for 12% of the global transportation-related CO2 emissions. And with cars, trucks, buses, trains, and boats having transitioned to electric motors, that percentage will grow significantly unless we take action. Beta Technologies is leveraging rapid advances in battery performance to make sustainable electric flight a reality. Their electric vertical aircraft, which you can see on the left-hand side of the screen, is called ALIA. It has zero operational emissions, and its batteries have a second life as an efficient means of charging from the existing electrical grid. ALIA was designed with a specific mission in mind: to transport organs for patients that are in critical need of transplants, but to do this in a sustainable fashion. Additional customers are realizing the need and benefits of an electric solution, and Beta has announced customers for cargo, passenger, and government use. By designing the aircraft around its proprietary propulsion system, they were able to create a product that is both efficient in forward flight and versatile, like a helicopter, in its ability to take off and land vertically. This is a tremendous leap forward for the aviation industry and creates a 3D solution to growing 2D problems like traffic, rural access, and geographic constraints. It's not hard to envision a future where there's a green delivery option and It's not hard to envision a future where there's a green delivery option available whenever you purchase something online and that item arrives at your house the same day, no matter where in the world you live. Creating the infrastructure to enable their aircraft is also incredibly important. Beta is building a network of charging stations throughout the United States and deploying immersive simulators that will train the next generation of electric aircraft pilots. To test, develop, and scale this business requires the creation of new networks, rapid feedback loops, and agile systems, and Beta uses AWS to ensure that their business will deliver the future we've all been waiting for. So let's talk about how Beta is using AWS. Through its in-flight test program, Beta gathers hundreds of gigabytes from the aircraft and uses it to analyze individual component performance both in the air and on the ground. In certifying a revolutionary new aircraft design and propulsion system, they must prove to the FAA that the aircraft is safe in all modes of flight and in every condition that it might encounter. Analyzing this data in real time and using high-fidelity simulations allows Beta to demonstrate its safety profile to regulators and accelerates their time to market. AWS plays a key role in enabling Beta's foundational IT and software infrastructure. While expediting valuable real-time data transfer into actionable design considerations, using Control Tower, EC2 instances, Transit Gateway, and backup DR services, AWS empowers Beta to push large amounts of data to teams of engineers waiting to ingest and analyze it in a host of different AWS-supported software applications. The resulting analysis drives agile decision-making processes that impact every employee at Beta, from fabrication, purchasing, mechanical and electrical design, software, and operations. The ability to iterate quickly gives them an advantage over legacy aerospace competitors and will enable the transition to a sustainable aviation future far sooner than otherwise would be possible. Beta has more than doubled their headcount this year, and as they scale, they know AWS will scale with them. Given the amount of progress in the sustainable transportation space, more and more people working from home, and more devices to keep online, there are ever-increasing demands on our power grid. Let's hear next from ION Energy's co-founder and CEO, Akhil, about how ION Energy is solving this complex issue. Over to you, Akhil.
Thank you, Danny, and thank you everyone watching this for your time. My name is Akhil Aryan, and I'm excited to speak to you about how we're leveraging AWS to accelerate the Earth's transition to an all-electric future. Starting very quickly with a brief introduction about myself. My name is Akhil, like I mentioned. Spent the last 12 years building software companies. ION is my fourth one. Spent most of my life using machine learning and AI for consumer applications. And then in 2016, had a conversation with my mentor, which led me to realize that there are so many problems that we need to solve as a species. and I should be solving bigger problems using machine learning instead of solving problems for just the consumer in a B2C context. And so I started ION in 2016 with a mission to accelerate the Earth's transition to an all-electric future. We're a very mission-driven company, and we like to think about the climate change as not only one of the biggest threats, but also one of the greatest opportunities that we have in front of us. And if you think about it, it's actually one of the most interesting opportunities to work on in our generation. In the last 10 years, we're sort of seeing this transition happening in the entire energy space, right? From generation, distribution, storage, and consumption. If you think about it, the first transition was really in the generation and distribution side of things, meaning that we are seeing even today the transition from fossil fuel power plants to renewable energy like solar and wind. We're seeing companies in different parts of the world like Africa, India, Southeast Asia, setting up mini grids and microgrids that are completely sort of off-grid, meaning that you have islands of energy grids that are basically generating their own power and distributing it to small communities independent of the national grid, which is sort of the disruption that we're seeing on the distribution side. And now, I would say in the last 5 odd years, we're sort of seeing a big transition on the energy storage and consumption side of things, meaning that with the uptake of electric vehicles, charging infrastructure, and the need for eliminating the intermittencies of renewable energy, we're sort of seeing lithium-ion batteries, new battery chemistries coming out, and we're also seeing new, I would say, technologies that are enabling the balancing of the grid because consumption patterns are changing completely. But it's not just the technology that's sort of going through a shift. We're actually seeing a more fundamental structural shift in the energy ecosystem as well. There's actually a shift of power that's happening from large utility companies to independent owners and operators. For as long as we can remember, the power when it came to energy was in the hands of a few big utility companies. But now with the uptake of things like rooftop solar, residential batteries, a big battery inside of your vehicle to grid technologies, charging infrastructure, shared utilization of assets, you're actually seeing the power shift from large utilities to independent owners and operators. And these independent owners and operators are not just people like you and me. It can also be large private equity firms that are investing in companies that are setting this up. But let's talk about what this means for us. What this means for people like you and me is that individual consumers can now start participating in the energy markets. We can see that if someone set up, say a rooftop solar installation with a residential battery or drives an electric vehicle, you can not only generate your own power, you can store this power. And let's say you're on vacation and you have solar power being generated, you can actually sell this power back to the grid and make money from the energy that you're generating. And so instead of only large companies producing power and sort of selling it to all the consumers, we can actually now become independent energy producers and also supply the power and make money from the infrastructure that we invest in. So that's how people like you and me can participate in energy. But if you think about large independent companies that are funded by private equity banks or big venture capitalists, they're actually investing in building large fleets of these new energy assets. And these new energy assets go from everything from a kick scooter fleet that you're renting by the mile or by the minute, all the way up to large solar power installations that are being used to generate power and sell back to the grid on a per unit of electricity basis. And so there are large companies investing in these new energy assets that are going to be used by practically everybody. It's a shared asset that is sort of used to supply to multiple users. And they're going to offset the cost over the entire shared utilization timeframe. But there's something really interesting when you start thinking about things at scale. When it's not just one person's home, when you're actually building out a fleet, you're actually investing a lot of money into that asset performing in a very specific way, having a very specific terminal value when the lifetime is over. And only then the business model of building out the fleet works. So now that these fleet owners and operators are setting out fleets of these new energy assets, they're also experimenting a lot with how they can increase the life and performance of these assets. And so if you think about it, it's not just the business model that's going through a shift, but it's also technology and decisions about which assets to invest in, how to manage them, how to improve the life and performance of those assets. Let's take an example. So if you think about batteries, which are now becoming a bigger part of our lives, previously batteries were just a few hundred grams inside of our phones and laptops. And now you have batteries that are a few hundred kgs that go inside of electric vehicles, large batteries connected to the grid, and so on. Let's talk about batteries for a second. Up until maybe, I would say, 10 or 15 years ago, we were using batteries called lead acid batteries, which didn't require any active management. So they were sort of dumb batteries that just sort of stored power and then delivered on demand. There were no advanced electronics managing these batteries. They typically cost between 1% to 2% of the asset. So imagine a small battery inside of your vehicle kickstarting your engine. And they needed to be replaced, maybe 1 or 2 years, every 1 or 2 years. So the lifespan, the energy density, the power density was quite low. However, in the last, I would say, 10 years odd, especially with a shift that's taking place towards electric mobility, we've seen the uptake of lithium-ion batteries. And lithium-ion batteries are far more energy and power dense, meaning that you can store a lot more power in a lot less space. But that also means that these batteries need active management for safety and performance. So you have something called a battery management system, a physical electronics device that goes inside of the battery to manage the state of charge and state of health of these batteries and make sure that they're performing safely, but also consistently throughout the entire life of the battery pack. These batteries not only deliver a lot more power, but they also cost a lot more, meaning that they'll typically cost between 5 to 10 times more than their lead acid counterparts. But the good thing is that they also last much longer. So the total cost of the energy is much lower, meaning that the life of a lithium-ion battery can be 5, 10, maybe even 20 years sometimes, depending upon the context that you're using them in. So now when you think about that from the context of an investor or a company that's buying a fleet of electric vehicles or setting up a large solar installation, they're experimenting with which lithium-ion chemistry they should go for. NMC, LFP, LCO, LTO. There are a lot of different chemistries out there. But not only lithium-ion, there are fundamentally new energy storage technologies, including, for example, hydrogen fuel cells, which is a shift away from energy storage, really. But you have a lot more options on the table when it comes to these new energy assets. And so the owners and operators that are investing in these assets are continuously experimenting with selecting the technology. And once they've selected the technology, actually leveraging the data to improve the life and performance of these assets. And that's sort of where we come in. What ION has built is a modern asset management platform for these new energy assets, which is called Altigo. Altigo is based on an asset agnostic architecture, which allows us to create digital twins of these new energy assets, ranging from electric vehicles like small scooters and commercial vehicles, all the way up to large solar plus storage installations, or just utility scale front of the meter energy storage systems that are being used for energy trading in some parts of the US. We built a platform that allows companies to create models of these assets in the cloud and then leverage the data coming from these assets to run analysis and predict what's the best way forward in terms of extending the life and extracting the highest revenue. So how this works is fundamentally on two pieces, by building digital twins and then leveraging machine learning and AI models to extract value from these assets. What I'll do is very quickly take you through the diagram that you're probably seeing right now. The way that we think about the future when it comes to asset management is that it's not just about monitoring the data. And so if you think about what exists today, you have some IoT platforms that allow you to transmit the data from a physical asset, visualize it in the cloud, and then it relies on humans to try and make analysis of that data. But in lots of cases, what lands up happening is that you're actually just getting siloed data streams instead of seeing the relationships between different types of data. In the context of Altigo, what we do is that we actually create what we call blueprints or digital twins of every single component and the system itself, and also the relationships between those components and the contracts that are being signed. So for example, if you were setting out, if you were buying a fleet of electric vehicles from X company, you'd want that X company to give you a warranty on the life of the battery, the life of the vehicle, given certain boundary conditions. And so what Altigo would let you do is not just model the vehicle, but also model every single component, like the battery, the motor, the brakes, the acceleration module, into the platform, and also model the warranty contract that you signed with company X. And so as the data streams start coming through, you can actually visualize whether the vehicle is performing as you expected. You can have different types of violation alerts, meaning that if the usage patterns might violate a warranty, you can find out beforehand. If there is a violation, you can look at what caused the violation and so on. So there's a bunch of analytics that are possible, but there's also something very cool. You can build your own algorithms on top of the data streams to then do predictive analytics and send over-the-air updates back to the vehicle. So we'll go through some of those examples as I go through. But what's important is to realize that Altigo is fundamentally a platform that allows you to create a digital twin and then leverage your own machine learning and AI models to run predictive analytics and send over-the-air updates back to the vehicle, or maybe even to the operators in order to operate those vehicles in a different way. Just in case you're wondering what are digital twins, we tend to hear the word a lot these days, but we don't necessarily know exactly what it is. It's actually very simple. It's a digital representation of a physical asset, all of the components of the asset, as well as the relationships between those components. So like I said before, in the context of an electric vehicle, a digital twin would be modeling or creating a digital representation of all of the key components inside of that asset. So in the context of vehicle, it would be the motor controller, the battery, and so on, right? So there would be a few critical components. You can decide what kind of resolution of data you want. So if you have sensors at like a sort of high resolution, meaning that you have sensors in every single part of your vehicle, you can model all of those sensors. And if you just have data streams coming from the critical components, you just have those critical components that get modeled. When you model all of the components, you can also create relationships between them. So you can create relationships between the motor, so that the motor and the battery can speak to each other. And then the battery can tell the motor how much battery is available, and so sort of modulate the amount of power or energy the motor is consuming. So essentially what we're saying is, inside of the platform, you can not only model the full vehicle, but also all of its components and all of its relationships. And once you've done that, you essentially have a digital twin of that physical asset. And then you can instantiate unique serial numbers or IDs for that digital twin. So if you have, say, 100 vehicles on the road, you create one template or one digital twin and then 100 instances of that digital twin, so that every single physical asset is connected to a unique instance of that digital twin. Now, why should you invest into creating this digital twin? Fundamentally, it's about two things, right? Like I said, the asset class is new, the technology is new, the environment, the market opportunities are different. And so to extract the highest value from your investment, you essentially want a platform that's helping you protect your downside and maximize your upside. And that's sort of the two parts that you can leverage a digital twin to sort of help with the predictions and decision making. So let's talk about the downside protection. Let's say you signed a warranty contract, like I said before. The analytics platform will help you identify usage patterns that might violate these warranties. If you have liquidated damages associated with availability of these assets, you can prevent yourself from being exposed to them by running forecasting and anomaly detection algorithms on the platform. And I'll talk about how we actually enable customers to leverage our anomaly detection algorithm and prevent these downtimes. On the upside, Like I said, there are new market opportunities that are coming up. There are different prices of energy that are available depending upon the demand and supply. You might have different prices available or different rates available depending upon the availability of the asset. And so what Altigo lets you do is simulate different environments and see what's the best way to leverage your asset and make the highest revenue. An example over here would be, imagine that you have a large solar power generating plant, like a solar plant, and you have a big battery, like a utility scale battery, connected to that solar plant, and you're generating power. You might want to decide when you want to supply the power that's being generated to the grid versus store it in the battery and then supply it later on. And so coming up with your dispatch optimization strategy, meaning, how much power are you generating? What's the price on the market right now? Do you want to store that power inside of a battery and supply it later, or do you want to supply it right away? And what is the cost associated with storing that inside of a battery? Because when you store the energy in a battery, you're actually charging and then eventually discharging that battery, and that has a hidden cost in the degradation of the battery. And so being able to simulate all of these different options and deciding the best one for you is something that Altigo will let you do on the revenue maximization side. So one of the things that it allows you to do really is, when you think about what I just explained, we're actually eliminating dependencies on a lot of different platforms that are out there. The environment today is such that when you build a company that's going to manage a fleet, you have to invest in lots of different software. So you want to design and simulation software that allows you to make better design decisions. You're going to get some analytics platform from an OEM. So let's say you're buying vehicles from 3 different car companies. You're going to get 3 different analytics platforms, and so you don't really have a holistic view of your deployment. You might invest in a separate data integration and machine learning platform, which is only for the machine learning team. You might have a separate operations and maintenance software, which is just for the O&M team. And so you basically have silos of data coming into different places, and you don't necessarily see the full picture. And so what we're trying to do with Altigo is to create a single digital twin, bring all of the data there, and then leverage enterprise safety and user-based access or role-based access control to give different teams access to the same data at a holistic level, but depending upon what their role inside of the company is. And so you remove the dependency on 6 different softwares, use a single one, and get sort of the full picture. We like to think of what we're building as an Iron Man suit for your teams, which really allows them to invest the time into building a single source of truth by building a digital twin, connecting all of the real-time data inside of that asset, and then slicing and dicing that data depending upon what each team wants to get done. But most importantly, building a repository of machine learning and AI algorithms that can be leveraged on top of the raw data, so that you're not just looking at beautiful visuals and graphs, but you're actually extracting actionable insights using your own machine learning algorithms that help you build competitive edge. So let me tell you how we use AWS to make all of this happen. We use a bunch of different AWS services. Of course, since we're an enterprise software company, we have an architecture that has 2 sections. One is the private subnet, and the other one is the public subnet. The web application that's actually used by the users is on the public subnet, and then all of the data, as well as all of the applications, essentially are running privately on the private subnet, and then we have a secure interconnection between the two. Any user logging in will essentially interact with the web app, which is a large EC2 server, whereas all of the devices that are sending in real-time data, we leverage Amazon's Elastic Beanstalk, so EBS, to sort of bring in all of the data and expand our capability to sort of grow as fast as our customers, really. And then depending upon the type of jobs that we're running, we'll use different services, meaning if our users or the platform itself is running a scheduled task, we'll sort of leverage SDS and have a worker pool, which allows us to sort of spin up new EC2 servers to run scheduled tasks. Whereas on the real-time data that's coming through, we have applications, for example, the anomaly detection that I spoke about earlier, for which we use AWS Kinesis. And so we'll have large chunks of data in real time flowing through Kinesis, gives both analytics to the user, but also then leverages the Kinesis Firehose to sort of store the data inside of S3. And then all of the pieces coming together into our database, which basically allows us to store data both for the short term, but also inside of Glacier, which is sort of our long-term data storage. An example of how we leverage AWS for Kinesis. So as the data sort of starts coming through, we have the Kinesis analytics that's allowing us to identify anomalous data, which sort of triggers our alert engine to notify our users, as well as sort of spin up the analytics inside of our environment that allows customers to sort of come inside and see what's happening. And when it sort of resolves it, you sort of bring the data back into Kinesis, use the Firehose, and like I said earlier, bring all of the data into S3 and pushed into our database. Now, what's very important to us is not just the fact that we can provide our users with this environment, but also allow them to leverage the environment to generate alpha and provide them with all of the tools that allow them to build their own IP. And so we spin up a virtual private cloud for every single customer that comes up, which is again something that AWS helps us do in a scalable way, because a lot of data is coming through for each of our customers, and they want their data to be inside of a single tenant environment. And so we'll spin up new instances of the virtual private cloud, give everyone access not only to the entire architecture that I showed earlier, but also with a robust API and SDK toolkit, which allows them to build their own applications using machine learning and AI. And together, we hope to build an all-electric future, not just with our software and our customers, but also with Amazon and with Amazon services that sort of help us bring all of this together. Thank you for listening to my talk, and I look forward to connecting with you guys offline.